First is join. In database management system, a join operation is a fundamental relational algebra operation used to combine row from two or more tables based on the related column between them. It allows from the retrieval of data that spans across multiple tables, enabling complex queries and analysis. Join operation typically involves matching rows from one table with the tables from other tables based on common column or condition known as the join predicate. A join in a database management system refers to the operations of combining rows from two or more tables based on the related information. A join in database management system refers to the operation of combining rows from two or more tables based on the related column between them. This operation is crucial for querying and retrieving data from the relational databases where information is often distributed across the multiple tables. Where information is often distributed across the multiple tables, the join process typically involves matching rows from one table's left tables with corresponding rows from the another tables, the right table, based on the common columns or conditions known as the join predicate. Join operation facilitate the retrieval of related data by establishing connection between the tables through shared attributes or relationships. Common type of join includes inner join, which returns rows with match value in the both tables, and outer joins, which includes rows from one or both tables, even if there are no matching values in other tables. Join are fundamental in relational database systems, enabling user to perform complex queries and analysis by combining and correlating information from different tables within the database. Efficient execution of join operations is essential for optimizing queries performance and ensuring scalability in database system. Join is an operation in database management system that combines the row of two or more tables based on related columns between them. The main purpose of join is to retrieve the data from multiple tables. In other words, join is used to perform multi-table query. It is denoted by bow tie. Syntax 1. R3 holds bow tie relation R1, join condition R2, where R1 and R2 are two relations to be joined, and R3 relation that will be hold the result of join operation. For example, temp hold bow tie a student's table S roll number is equal to enrollment and the table name exam, where S and E are the LS of the students and exam respectively. There are different types of join. In database management system, join are fundamental operations used to combine data from multiple tables based on the record columns. The main types of join includes inner join, outer join. Inner join in database management system is crucial operation used to merge the data from two or more tables based on specific conditions or join predicates. This type of join retrieves only the row where there is a match between the values in the specified column. Outer join. An outer join in a database management system is a type of join operations used to merge data from two tables based on a specified condition, while also including unmatched rows from one or both tables. Unlike inner join, which only return rows with matching values, outer joins ensure that all rows from one or both tables are included in the result. Even if there is no corresponding matches, there are three main types of outer join: left outer join, right outer join, and full outer join. We'll discuss one by one. The left outer join includes all rows from the left table and match rows from the right table, while right outer join includes all rows from the right table and matching rows from the left table. A full outer join returns all rows from the tables, including unmatched rows from their tables. Outer joins are commonly used when users need to retrieve data from one table while also including related to data from other tables. Outer joins are commonly used when users need to retrieve data from one table while also including related data from another table, even if there are no direct matches between them. An inner, an inner join is a fundamental operation in database management system used to combine data from more tables or related columns. The process of performing an inner join involves comparing values in the specified column across the tables and including only the rows where there is a match. This ensures that the resulting data set contains only the data that is shared between the tables based on the specified criteria. For example, in the database containing information about the customer and their order, an inner join might be used to link customer records with corresponding order details based on the shared customer ID column. This allows users to correlate and analyze related data from different tables efficiently. Overall, inner join are powerful tool for querying and analyzing relational databases, facilitating the retrieval of relevant and connected information from multiple tables based on a specified condition. The inner join is a fundamental operation in database management system used to merge data from multiple tables based on related columns and return only the row that have matching values across the table. There are two main type of inner join: EQ join and natural join. EQ join is a subset of inner join where the join condition specifies the equivalence using equal operator. It matches row from the table based on the equality of values in a specified column. EQ join, the quality condition. In EQ join, the equality conditions serve as the join predicate, specifying which column to compare and match between the tables. For example, if we have two tables, employee and department, in EQ join might be performed based on a shared column such as department ID, where only the row with the matching department ID values from both tables would be included in the result set. Natural join. Natural join is another Natural join is another subtype of inner join where the join condition does not require explicit comparison operators. Instead, it relies on the column with the same name and domain in the both tables. In the natural join, there must be at least one common attributes between the tables, and the join operator automatically matches the row based on the common attributes. In natural join, the join condition is implicit, relying on the column with identical name and data domains in both tables. The join operator the join operator the join operation pairs rows where the value in the common column are equal without the need for specifying the join predication or comparison operation. This makes natural join. The join operation pairs rows where the values in the common columns are equal without the need for specifying the join predicates or comparison operators. This makes natural join convenient for simplifying the queries and reducing the needs for explicit join condition. Inner join, where eqjoin or natural join are powerful tool for combining data from different tables in database management system, facilitating different retrieval of related information based on a specified condition or column similarities. Outer join. The outer join is the type of join that retrieve matching as well as non-matching records from related tables. There are three types of outer join: left outer join, right outer join, and full outer join. Full outer join. In full outer join, all the rows from the both tables are inserted in the table. Left outer join is also called the left join. This type of outer join retrieve all records from the left table and retrieve matching records from the right table. Right outer join, it also called right join. This type of outer join retrieve all records from the right tables and retrieve matching records from the right tables. So these are about the joins. Now, apart from these important concepts, there are a few applications we need to know. Some applications of relational algebra. These applications are found in NoSQL databases, big database system, object relational mapping, graph databases, in stream processing, transaction management, and the last is in the security segment and in multimodal database. Now we will going to discuss all these applications in detail. Relational algebra in NoSQL databases. Relational algebra is like a set of rules we use to organize and work with the table. Relational algebra is like a set of rules we use to organize and work with data in databases. It helps us ask questions and do things with the information we have stored. In NoSQL databases, which are a bit different from the usual databases, we still use some of these rules, but we might have to change them a bit to fit the way NoSQL database work. In NoSQL databases, which encompasses various types, have to change them a bit to fit the way NoSQL database work. In a SQL database, which encompasses various types like document oriented, key value, column family, and graph database. The application of retrieval application varies. For example, if we have no SQL database that store information in documents, kind of like how you might organize files on your computer, we can still use relational algebra to find specific documents or to show only certain part of them. Similarly, in NoSQL database that store data in different ways, like in a big table or as a key value pairs, we can still use relational algebra ideas to search through the data and pick out what we need. So, we can still use relational algebra ideas to search through the data and pick out what we need. So even though NoSQL databases and traditional databases are a bit different, we can still use some of the same idea from relational algebra to make the sense of the data we have. Some other example of it are document oriented database like MongoDB, relational algebra operation like selection and projection can be adapted to query and manipulate graph database, for example, of Neo4j. Relational algebra concepts are utilized to traverse and query graph structures. Operation like selection, filtering nodes or relationship based on the properties, and just join merging data from different parts of the graph can be implied. Key value store. Example is Redis. While lacking a schema, some relational algebra principles like selection and projection can still be applied to filter and shape data retrieval from the key value pairs. The last is white column stores. For example, Apache Cassandra. Relational algebra ideas can be used for querying and transforming data stored in white column. Relational algebra ideas can be used for querying and transforming data stored in white column format. Operation like selection, filtering rows based on the column values, and projection, selecting specific columns can be applied. The other application in the relational algebra is big data system. Relational algebra is a mathematical framework for manipulating and querying data in a relational databases. Also find application in big data system. In this system, which handle massive volume of data distributed across multiple nodes, relational algebra principles are adopted and extended to support large-scale data processing and analysis. Some key aspects includes query language, distributed processing, data transformation, lakes and warehouses, analytic and machine learning, streaming and real-time processing. Relational algebra in object-oriented mapping is called ORM. Relational algebra is a foundational to object relational mapping, a programming techniques used to bridge the gap between the object-oriented programming paradigm and relational database. In object relational mapping, relational algebra concepts are applied to map object-oriented data structure to relational database tables and vice versa. Here, how relational algebra is used in object relational mapping. They are different. Object relational mapping, mapping object to relations, querying data, and the last is data manipulation. Now let's me explain the application of relational algebra in graph databases. Relational algebra and graph databases are two distinct but related concepts in the realm of database management system. Relational algebra is the formal mathematical framework used to query and manipulate data in a relational databases, while graph databases are the type of NoSQL database optimized for storing and querying graph structured data. Relational algebra provides a theoretical framework for querying and manipulating data, which can be adopted and extended to support graph queries in graph databases. Although they operate in different domains, there are connections between relational algebra and graph databases. Graph data model versus relational model. Next is mapping graph queries to relational algebra. Graph query languages and relational algebra extension for graph. The next is relational algebra in stream processing. Relational algebra in stream processing involves applying relational algebra concepts to manipulate and query continuous stream of data in real time or near real time. Relational algebra in stream processing helps us manage and make sense of the conditions flow of data, enabling us to extract variable insights and react quickly to changing conditions. For example, if you are monitoring temperature sensor and want to know when the temperature exceeds a certain threshold, you can use relational algebra to filter out the relevant data points from the stream. Here, how it works. There are different types. A stream data model, relational algebra operations, a stream processing framework, continuous queries, and windowing. Relational algebra and security. As we know that algebra and security are interconnected aspects of database management system and which play a crucial and critical role in safeguarding the confidentiality, integrity, and availability of data. Here's how they relate: a set of rules for working with the database, while security is about keeping that data safe. Relational algebra and security. As we know that algebra and security are interconnected aspects of database management system and which play crucial and critical roles in safeguarding the confidentiality, integrity, and availability of data. Relational algebra is like a set of rules for working with data in databases, while security is about keeping the data safe. Here's how they relate: access control, next is data encryption, auditing and logging, role-based access control, and parameterized queries. Relational algebra in multimodal databases. Relational algebra application in multimodal databases adopts its operation to handle diverse or different data models like relational, document-oriented, and graph-based structure. It basically serves as unified framework for manipulating, manipulating, and optimizing data operations across various data models, facilitating seamless integration and analysis of heterogeneous data sources within the single system in multimodal database, which can handle different types of data like table, documents, graphs, and more. Relational algebra helps us work with all these different types together. The unified query language. data modeling mapping, query optimization, data integration, flexibility, and consistency and integrity. Relational algebra helps ensure that the data stay reliable and accurate even when we are dealing with the different types of data. It keeps things organized and in order no matter what we are working with. In today's lecture, we have discussed about the relational algebra, fundamental operators. Now it's time to test your knowledge by assess your performance and track your progress with some questions. Your answer will enhance your answer will enhance your concepts as well as make you more aware about the topics. The today's question to test your knowledge are: explain the purpose and significance of relational algebra in database management system. The second question is: how does relational algebra contributes to query optimization and performance improvement in database system? The third question: discuss the role of selection and projection operator in query formation and data retrieval in relational algebra. The last is explain application of relational algebra in detail. In our lecture today, we have navigated through the concept of data modeling using the relational algebra, fundamental operators. In today's lecture, we have discussed so many concepts and applications of relational algebra with the help of examples. I wish you enjoyed this lecture and acquire vast knowledge about today's topic. Hope to see you soon in the next lecture.